Hello, everyone. Welcome back. Today, we're going to go through two different exponential growth word problems. So, I first just want to dive into how can we go from the word problem to the equation, because I think that's the problem most people have. We will also go over, of course, solving the equation, but I don't think that's the main reason people are here. People are probably here to know how do we go from the word problem, from reading the word problem, to coming up with our equation. Okay, so the great thing about all exponential growth equations is they all follow the same pattern, where y is the final amount, so the amount we will have at the end after the time has been elapsed. A is the initial amount, so how much did we have before the time was elapsed. And then we have 1 plus r, where r is the growth rate as a decimal. So if we have like a percentage here, we wouldn't just put the number and ignore the percent. We would convert the percentage into a decimal number and put that in for r. So that's something important to keep in mind. And then t is the time, right? So how much time has been elapsed. And I should be more specific here. How much time with respect to the growth rate has been elapsed, right? So sometimes we may have to adjust that, the way that we plug that into our equation, depending on what the growth rate is, right? Is the growth rate happening, is the growth rate happening once a year, right? Is it happening once a minute? Is it happening every hour, etc., right? So the time needs to be in the same units that our growth rate is in, and that's really important. So sometimes we do have to convert the time. Okay, I'm going to give an example here. It says Molly invests $10,000 for 12 years at a 7% return per annum. So that's per year. So essentially, what this means is every year she gets a 7% return on her money. So whatever she had the previous year, this year she has an extra 7%. So she still has the entire $10,000 plus 7%. Same thing with the second year, right? Then she has the $10,000 plus the interest she earned last year, plus an extra 7% on top of both of those together. And so we want to know, how much does she have after these 12 years have been elapsed? So what do we not know here? We don't know the final amount, but we know everything else, right? We know the initial amount. So I'm going to write this down. We don't know the final amount. That's what we're trying to figure out. But we do know the initial amount was $10,000. That's how much she originally invested. The growth rate is 7%. So I'm going to put that as 0.07, just because remember, we're turning that into a decimal. So we wouldn't just write 7 here, we would write 0.07. And then it is for 12 years is the time. So time would be 12. And notice that here it says the 7% return is per annum or per year, and she's doing it for 12 years. And so in this case, we don't have to convert the time because, 12 years, we're talking about years in terms of the return rate, in terms of our growth rate, and years in terms of the time. And so we're using the same units for both, and that's what's important. Okay, so then we're going to have y is equal to 10,000 times 1 plus r to the power of 12. 12 is equal to 10,000 times 1.07 to the power 12, which, let's see what that's equal to. I'm going to grab a calculator and type in 1.07 to the power of 12. And then I'm going to multiply that by 10,000 and get $22,521.92. So therefore, the amount she has after 12 years is $22,521.92, which is pretty cool. She has more than doubled her money after 12 years just by leaving it there and enjoying that 7% return per annum. Okay, let's try another one. A Florida high school has 1,340 students. Each year, the number of students increases by 10%. About how many students did the school have 5 years ago? Okay, so for this one, we know the final amount. We know that y is 1,340. However, we don't know a. We don't know the initial amount. We would like to know how many students were there before the 5 years of time was elapsed. We also know the growth rate is 0.1, right? Because 10% as a decimal is 0.1. And the time is 5 years, so t is equal to 5. And again, in this case, we actually don't have to convert anything with respect to time because it's each year, the increase is per year, and the units that they gave us the time in was 5 years ago. And so therefore, we can just keep these as is. Okay, so our original equation is y is equal to a times 1 plus r to the power t. That means 1,340 equals a times 1.1 to the power of 5. That means a is equal to 1,340 over 1.1 to the power of 5. And if I type that in a calculator, I get 832. So therefore, 5 years ago, so before these last 5 years happened, 5 years ago, there were about 832 students enrolled in the Florida high school. All right, well, good work, everyone. And next day we'll be talking about exponential decay.